Oh, wow, echo. Hi everyone, welcome to Makerspace Online Learning. So today's episode is dedicated to the grade 1 students because we're gonna keep talking about light and its properties. Makerspace.
Check it out, Makerspace, yes, Makerspace. Online.
Good. So today we're going to talk about maths. Today we're going to talk reflection, refraction, and total internal reflection. Wow. The first property we're going to talk about is reflection. For that, we're going to need a mirror. Can you see yourselves? Look at me. I'm in there. Look at me. It's Mr. Edgar. Hi. A mirror. Our SpongeBob box with the laser pointers. We're going to need one laser pointer. It's going to be very, very simple. We just want to understand that certain materials have reflective properties. That means that light bounces on it and goes back. Let's see how it works. So we get our mirror. Yay. Going to place it in here. I get my laser pointer. I press the button and look. What happens? So the laser beam gets reflected on the mirror and comes down here. Do you think that from the mat it will go somewhere else?
Well, let's discover that. Our laser pointer sends the laser beam to be reflected on the mirror. It comes down to the blue cutting mat. And from there, does it go somewhere else? Does it get reflected again? Can you see the red dot in there? Could you see the red dot in the experiment? So that means the light needs to bounce again to come to your eyes. So the answer is, the beam goes somewhere else, it gets reflected again. But now it's very, very weak, but enough for us to see it.
So to this we call reflection. It is a property that certain materials have. Let's move on to the next experiment. Okay, so that was very, very easy to understand. Now let's run another experiment to understand refraction. Do you know what that is? What is refraction? Refraction, it's what happens to light when it changes the medium that it's traveling in. Let's see. So, for this experiment, we're going to need very simple things. We're going to need a bowl, an object, and water. Here we go. Bowl. You take the object and you put it in, so you cannot see it, right? You get the water and prepare to be amazed. Magic. It's magic. Now you can see it, right? No, maybe that's the wrong experiment. Here we go again, this time with the proper object. The bowl is empty. We have more water in our jar. A new object. This time a coin. I'm sure that it will stay in the bottom of the bowl. Very good. So you cannot see it from there, but now, prepare to be amazed. Here we go. Can you see me? Ta-da! Now you can see the coin. But how? What happened? Mystery.
Well, it's not that much of a mystery. Let me explain it to you. When the bowl is empty and our coin is in there, we cannot see the coin. Our vision is blocked by this side of the bowl. Because the water bends the light. Then we can see the projection of the coin right in here. So water causes the light to slow down, Remember our experiment with the prism, where we created a rainbow? When the light from the sun hits the prism, it slows down and it decomposes light in all of its different wavelengths.
I just remembered something else that we can do with this jar of water. So we're going to need the jar of water and a marker and a piece of paper. You can reuse it, right? Okay, grab your piece of paper. Well, actually, I'm gonna fold mine and I'm gonna draw an arrow. See? I place my jar of water in here, right in front of you. And now I place the paper right behind the jar. Try to guess to which side is the arrow pointing. Did you guess it right? Let's do it again. Okay, to which side is it pointing? What?
So what makes the arrow switch? The bottle of water in the middle works as a convex lens, and it bends the light as the light passes through it. Where the light crosses, it's called the focal point. If the arrow is behind the focal point, the light reverses and so does the arrow. But if I bring the paper to this point, you'll only see it on the right side. That's what made the arrow change.
And now to talk about the total internal reflection, we are going to need to go to the toilet. I'm going to take the camera with me and maybe a laser pointer and a pet bottle. Excuse me.
Make a space, make a space.
Now that was pretty cool, right? For that experiment, if you have a laser pointer, some of you have, you just need a bottle. Ask your parents, because it might be tricky and you can cut yourselves. You need a knife, cut a hole in it. You see that little hole? That's enough.
What is happening in this experiment? It's actually quite simple to explain. As the laser beam finds the hole in there, the light keeps bouncing inside the water, so we never lose it. It's always bouncing and bouncing and bouncing. So we keep all of the light, all of its energy comes with the water. And then when it hits my hand, we're able to see it. That's why it's called total internal reflection. That means that all of the energy that travels inside internal gets reflected in the end.
Make a space, make a space.
It is almost time for us to go, but before that, I would like to ask grade 1 students to find 3 materials. One that is opaque, one that is translucent, and another one that is transparent. Take a photo and post it on Seesaw so I can see it. Alright, and that's it. Hope you guys had fun. Bye! Make a space.
Make a space. Check it out, make a space, yes. Make a space, make a space.
to play with Legos.